Let's use our source mass formula to solve a few more examples. So in this example, the gravitational field strength on planet B is 7.4 newtons kilogram. If planet B has a radius of 6 times 10 to the 5 meters, what is the mass? Like always, I like to write out the information that we are given on the left side. We know that there is a gravitational field strength of 7.4 Newton kilograms on this mysterious planet B. We also know that planet B has a radius of 6.0 times 10 to the 5. That's to determine what is the mass of the planet. So, using our source mass formula, we have to G m1 over r squared. We want to rearrange this to be solving for m. By r squared, canceling those two out. And to get this m by itself, maybe I'll rewrite it to make it a little more neat. We now have r squared times g is equal to g m1 divided by the gravitational constant. That will give us a final formula of m is equal to the gravitational field strength times the radius squared divided by the gravitational constant. So plugging in is 7.4 newtons per kilogram. Remember, it's not 9.81. That's on Earth. On this mysterious. Times the radius, 6.0 times 10 to the 5 meters squared, divided by the gravitational constant, 6.67 times 10 to the negative 11 kilograms squared. When you plug that in, you're going to get a final answer of 4.0 of planet B, not of a test object. We don't have a test object. You're figuring out the mass of the source. Alright, in this next example, you can see that I've put about 2 pounds of whiteout on here, but that's because the video kept cutting out. So here's hoping that the third time's a charm and this works. On this example, we have a distance from the Earth's center has a gravitational field strength, we want to find at what distance from the Earth's center is the gravitational field strength 7.33 newtons per kilogram. So in this example, as with every example, I like to put all the information I'm given on the left side. I am given the Earth's gravitational field strength is equal to 7.33 newtons per kilogram. Now before this gets too confusing, on the Earth's surface, yes, the gravitational field strength is 9.81 newtons kilograms. But nowhere in this question does it say we're on the Earth's surface. We're actually trying to figure out how far away from the Earth's center we are. We also know because the gravitational field strength is weaker than 9.81, we are going to be further away from the Earth's center. Remember, the further away you get from the center of a mass, the weaker your gravitational field strength is going to be. What we do know also from our formula sheet is the Earth's center has a mass or the Earth itself has a mass of 5.97 times 10 to the 24 kilograms. We want to determine how far away are we from the Earth's surface, from the Earth's center. So to do this, we are going to use our source mass formula, which is G is equal to the constant times the mass divided by the radius squared, or the distance squared. Our goal is to get this radius by itself. To do that, we are going to multiply both sides by r squared. That's going to cancel it out on the right, leave us with r squared times the gravitational constant is equal, the gravitational field strength is equal to the gravitational constant times the mass. Again, we want to get this r by itself. We'll divide both sides by g. And that'll leave us with r squared is equal to g m1 over the field strength. So our last step wants us to get rid of that squared. So to get rid of a squared, we take the square root. But if we do it to one side, we have to do it to the other. So now we can plug in all our information to solve for the distance we are away. To do that, we have r is equal to the gravitational constant, 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared, times the mass, which the mass of the Earth is 5.97 times 10 to the 24 kilograms, divided by our gravitational field strength, which is 7.33 Newton per kilograms. We're going to solve all this, but remember, we need to take the square root as well. So once you plug that all into your calculator and solve, you're going to find that you are 7.37 times 10 to the 6 meters above the Earth's center. In the last example, we know that Earth has a mass of 5.97 times 10 to the 24 kilograms. We want to determine the gravitational field strength at an altitude of 600 kilometers above Earth's surface. So if we are 600 kilometers above Earth's surface, that means that we are, if I draw this out, if we have the Earth and we are 600 kilometers above the surface, that's the same as being 600,000 meters above the surface. And we also need to include the the distance from the center of the Earth, right? Not just from the surface, but from the center to the surface, plus the surface to where we are. So the radius of the Earth from your formula sheet is 6.37 times 10 to the 6 meters. So our r is going to be 6.37 times 10 to the 6 meters plus 600,000 meters, which means we are 6.97 times 10 to the 6 meters from the center of the Earth. We also know the Earth's mass is equal to 5.97 times 10 to the 24 kilograms. So now that we have all of this information, we can use that to determine the gravitational field strength above the Earth's surface, or 600 kilometers above the Earth's surface. Using our test mass formula, using our source mass formula, G is equal to the constant times the mass divided by the distance squared. So you have 6.67 times 10 to the negative 11 Newton meters squared divided by over kilograms squared times the mass, 5.97 times 10 to the 24 kilograms divided by the distance, 6.97 times 10 to the 6 meters squared. When you plug that in and solve, you're going to get a gravitational field strength of 8.20 newtons per kilogram. Again, this is a vector. If we are away from the Earth, it feels like we get pulled down towards the Earth. So our direction is going to be down. Sorry for jumbling my words quite a bit on this last example. It's been a long day of recording lessons. If that makes no sense, if you need more help, please let me know. If not, good luck, and I'll see you later.